Ever just, you know, stop and think that maybe reality isn't quite what it seems on the surface?
Absolutely. That maybe the universe has this whole underlying operating system we're just starting to glimpse.
Exactly. And today we're diving into something along those lines.
Yeah.
Could gravity, the force holding everything together?
Could it be something else? Something more than just a fundamental force?
Yeah, maybe even a sign that reality itself is, well, computational.
That's the core question we're tackling. We're looking at a really fascinating new study suggesting gravity might be, well, emergent, a byproduct of the universe acting like a massive quantum computer.
Okay, wow. And this comes from physicist Melvin Vopson, right, at the University of Portsmouth.
That's the one. He's putting forward this pretty radical new perspective on how the cosmos might actually work, basically linking gravity to information processing.
So that's our mission for this deep dive then. Let's try and unpack this theory, get our heads around the main ideas, and, explore what it could all mean.
Sounds good. Where should we start? The central idea itself.
Yeah, let's do that. What's the absolute core of Vopson's proposal?
Okay, so fundamentally, he's saying gravity isn't a basic force like, say, electromagnetism.
Right, not like magnets attracting or repelling.
Exactly. Instead, he suggests it's an emergent phenomenon. Think about wetness. Water isn't inherently wet at the single molecule level, right?
Uh-huh.
Wetness emerges from how lots of H2O molecules interact.
Okay, I get that analogy.
So Vopson thinks gravity is similar. It emerges from the universe doing something even more fundamental, organizing and processing information.
And that's the leap to the universe as a giant quantum computer. How does that fit?
Precisely. The idea is that the universe, at its very base level, might be running computations using quantum mechanics.
Quantum. So not like my laptop. We're talking qubits, superposition, all that stuff.
Exactly. Qubits can be 0, 1, or both at once, allowing for vastly more complex information handling than regular bits.
Okay.
And in this picture, gravity isn't a force pulling things, but more like a consequence of these incredibly complex, ongoing quantum calculations.
So information isn't just in the universe, it's like what the universe does.
That's a great way to put it. Vopson uses something called the second law of information dynamics. It's a bit like the second law of thermodynamics, but for information.
Which says things tend towards disorder, entropy.
Right, but the infodynamics version suggests information tends towards a state of minimum entropy. Basically, the universe tries to keep its information content as organized and compressed as possible.
Organized and compressed. Like kiting up your hard drive.
Yeah.
Getting rid of junk files.
Huh. Yeah, that's actually a really good analogy, like a computer trying to save space and run more efficiently. Vopson thinks the universe might have a similar drive.
And gravity is how it does the tidying.
That's the idea. He actually said it's a new way to think about gravity, not just as a pull, but as something that happens when the universe is trying to stay organized.
That really flips the script on gravity. Now, you mentioned his earlier work, too. Something about information having mass.
Yeah, that's a crucial piece of the puzzle for him. His previous research proposed that information isn't just abstract, it actually has a physical quality mass.
Whoa, okay. How?
He suggested that elementary particles like electrons and quarks, the basic building blocks, they don't just have properties like charge and spin, they also fundamentally store information about themselves.
Like a tiny data packet describing the particle.
Exactly, kind of like how DNA stores the blueprint for a living thing. He's proposing something similar, but at the most fundamental level of physics, information intrinsic to the particle.
Okay, so particles carry information, and that information has mass. How does that connect back to gravity emerging from computation in this new study?
Okay, this is where it gets really interesting. He introduces this concept of space pixelation.
Space pixelation.
Yeah.
Like the universe is running on a low-res monitor.
Sort of.
Okay.
He suggests that space itself isn't smooth and continuous, but it's actually made up of incredibly tiny, discrete units. Elementary cells, he calls them.
Like fundamental pixels of reality.
Pretty much. And these pixels or cells act as a kind of data storage medium for the universe.
Storing what?
Information about what's in them. It defines the properties, the coordinates, basically everything about matter within this. Well, he calls it a space-time simulated construct.
Simulated construct. We'll come back to that. But how is the information stored?
Very simply, actually, in a binary way. An empty cell is a 0. A cell with matter in it is a 1.
Zeros and ones, like regular computer code.
Exactly. And Vopson himself points out this is basically identical to how a digital computer game, virtual reality application, or other advanced simulation would be designed.
Okay, my mind is officially a little bit bent.
Right.
So we have pixelated space storing zeros and ones. How does gravity pop out of that?
Right. So imagine one of these tiny space cells. If it has the capacity to hold, say, two particles to ones, Vopson argues the system will naturally find it more efficient to merge them.
Merge them.
Yeah, to bring those particles together into a single larger particle within that same cell, or maybe move them into adjacent cells that eventually merge. The point is consolidation.
Why would it do that?
To minimize the total information content, think about it from a computational standpoint. It takes less processing power, less information to track one combined object than it does to track two separate objects.
Ah, okay. Fewer items in the database, less work for the cosmic computer.
Exactly. It's an optimization process. And that tendency for particles, for matter, to clump together to reduce the informational load.
That is gravity.
That's what Vopson proposes. That feeling of attraction we call gravity is actually the universe trying to run more efficiently to compress its own data.
So its conclusion is basically,
He says, therefore, it appears that the gravitational attraction is just another optimizing mechanism in a computational process that has the role to compress information.
it's not a force pulling, it's a system optimizing.
Wow. It completely reframes it.
Okay, the implications here feel huge. If gravity isn't fundamental, but just a side effect of cosmic data compression, but what does that even mean for physics?
Well, it throws open some massive questions, doesn't it, about the fundamental nature of reality itself.
And it brings us back to that simulated construct idea he mentioned. Does this lean towards us living in a simulation?
Vopson certainly suggests it makes that possibility more plausible, or at least something to consider more seriously. If the universe operates on computational principles identical to simulations, well, you draw your own conclusions, but that's still speculative, of course.
Of course. But even without going full matrix, if this core idea about gravity and information is right, that alone changes everything, doesn't it?
Absolutely. It would mean our understanding of the universe's basic mechanics needs a major overhaul. It suggests this deep link between information theory, computer science, and fundamental physics that we haven't really appreciated.
It implies the laws of physics might actually be like algorithms running on this universal hardware.
That's one way to interpret it, yeah. That the fabric of space-time and the forces within it are deeply tied to information processing.
So wrapping this up a bit, the big takeaway is this truly mind-bending possibility that gravity, this thing we experience every second, might not be fundamental at all.
Right. It could be an emergent effect of the universe behaving like a giant quantum computer, constantly shuffling and optimizing its own information.
It's a perspective shift, really, moving from thinking about forces acting on things to thinking about the underlying informational rules producing those effects.
Exactly. A universe where information and computation aren't just things that happen in it, but are what it fundamentally is, or at least what it fundamentally does.
Which really leaves you pondering, doesn't it? If gravity is just one emergent outcome of this cosmic computation,
Yeah.
what else might be? Are other forces, other physical laws we think are fundamental, also just optimization processes, different facets of the universe trying to compute reality as efficiently as possible? What else is emerging from the code?
That's the big question to chew on, isn't it? A whole new way to look at the cosmos.